Welcome to this video on testing and debugging Spring AI applications. After watching this video, you will be able to identify how to use Spring AI evaluators for testing and apply testing and debugging strategies specific to Spring AI applications. Testing Spring AI applications has some unique challenges compared to traditional Spring applications. One issue is response variability. AI models might return slightly different responses to the same prompt each time. Hallucination risk is another issue. AI models can generate incorrect information, a phenomenon known as hallucination. Additionally, context window limitations are an issue when AI models have token limits that restrict how much information a user can process at once. To demonstrate how to test Spring AI applications, let's start by creating a simple Spring AI application that uses OpenAI. This will give us something to test later. First, set up a new Spring Boot project with the necessary dependencies. This code snippet sets up a basic Spring AI application by including dependencies for building a web service with Spring Boot Starter Web, integrating OpenAI models with Spring AI, OpenAI Spring Boot Starter, and supporting testing with Spring Boot Starter Test. So, let's create a simple service that will interact with an AI model. In this code snippet, the code defines the Weather Advisor service as a Spring-managed component. It uses a chat client to send a prompt to an AI model that will return a response. This allows the application to generate clothing advice based on weather and temperature input. Next, we set a simple controller to expose this as an API. This code snippet shows that we've created a Weather Advisor controller that defines a clothing advice GET endpoint, allowing users to receive AI-generated clothing advice. We'll also add the API key in application.properties. Unit testing is important to ensure your application works as expected. However, testing AI responses can be challenging due to their variability. Let's see how to approach this. Take a moment to examine the code. Notice in this code unit that we're testing the application by mocking the chat client to simulate AI responses without making real API calls, and then verifying that the Weather Advisor service returns a non-null, non-empty clothing advice string. Spring AI provides specialized evaluators to assess the quality of AI responses. These include the Relevance Evaluator to measure how relevant an AI-generated response is to a given prompt, and the Fact-Checking Evaluator to evaluate factual accuracy. The Spring AI Evaluator API allows you to implement various strategies to evaluate model responses. This is particularly helpful for testing AI applications where the exact output is unpredictable. Here's an example of using the Relevancy Evaluator. Take a moment to examine the code. This code snippet shows that we've used Relevancy Evaluator to automatically check if the AI-generated clothing advice is relevant to the user's original weather question. This ensures quality by asserting that the response passes the evaluation. For more comprehensive testing, we can use test containers. In this code snippet, we've used code that performs integration testing by using test containers to create an OLlama AI model inside a container. This allows the Weather Advisor service to interact with a live API for end-to-end testing. It verifies that the service generates appropriate clothing advice based on actual AI responses. You might encounter various issues when working with Spring AI applications. Let's explore some debugging techniques, starting with logging AI interactions. It's important to log your prompts and responses so you can understand what's happening. Take a moment to review the code snippet. This code snippet shows how a logger is used to record both the prompt sent to the AI and the response received, helping to monitor and debug the communication between the Weather Advisor service and the AI. Another debugging technique you can use is Spring's debug configuration. You can enable Spring debug mode in application.properties. You can also debug by testing with simple known prompts. When debugging, use simple prompts with expected responses. In this code snippet, we use the Hello World prompt. Additionally, you can use a debugging technique for AI service errors. Because AI services can fail, you should implement proper error handling. The code shown here uses getClothingAdvice with error handling to catch exceptions when the AI service fails, and it logs detailed error messages, making it easier to identify and diagnose problems. By recording errors, you can quickly trace issues during development or in production without the application crashing. You can also implement advanced testing techniques. Sometimes, you need to validate that AI responses contain the required information, so you use content validation testing. In this code snippet, the test checks that the AI response to hot, sunny weather includes key terms such as hat, sunscreen, or light, ensuring the advice contains relevant information. Another advanced technique includes ensuring responses aren't too long. In this code snippet, we've used response length testing. This ensures that AI responses are concise by checking that the output contains fewer than 50 words. In this video, you learned that Spring AI extends familiar Spring principles to AI applications, but introduces unique testing challenges such as response variability, hallucination, and context window limitations. Testing approaches include mocking AI responses in unit tests, using Spring AI's specialized evaluators, such as Relevance Evaluator and Fact-Checking Evaluator, and performing integration testing with test containers. Debugging techniques involve logging prompts and responses, using Spring's debug configuration, testing with simple known prompts, and implementing error handling to catch and log AI service failures. Advanced testing techniques, such as content validation and response length checks, further ensure the quality and reliability of AI outputs.